So before we move on to some more actual circuit examples, I want to give you more familiarization with the Node-RED IDE, Integrated Development Environment desktop itself. You see, you have a lot of nodes over here. These are the dashboard nodes from this down to here. I've also added the LED node and a node called SVG, which is a very powerful graphics generator node, which we may get to later. We've already used the LED node, but there are a lot of other nodes that create a dashboard, and these are specific to the Node-RED dashboard that we created over here. For example, this LED is associated with this node, which we call a widget. It's a widget when it shows up on a dashboard we can browse to through Node-RED. These are other widgets, and I can create many other widgets in here. Now, let me show you one of the most powerful areas of Node-RED. Here's our hamburger menu, and if we drop this down, we see a number of choices. We can view a number of different things, but very importantly, just as a quick overview, we can import flows, whole flows, or sections of flows. We can highlight a flow, and we can export it. And what happens is it exports it as a bunch of text, raw text. Let's do that. Let's export this as raw text of the current flow, and let's copy it to the clipboard. Okay? And if now, later on, we save that clipboard into a text file, save it somewhere, and then we can highlight all the contents and import it. And let's do that. Let's just say it was in our clipboard, and here's all this text. We import it. Okay, we import a copy, and what happens is it creates a new flow, and lo and behold, it shows up as a new flow. And so we can actually go in and save copies of entire flows. And these are tabs, by the way. These are each flow tabs. Each one creates a new tab on our dashboard up here. So let me get rid of this. I don't want two of these here. Let me just delete this now. Let me go back to the flow that we had in the beginning. So that's import and export. Very powerful to be able to import and export your work and save them as backups. We can add flows, we can rename them, we can delete them. But the easiest way to do it is up here by double-clicking on the tab and renaming it. We can enable or we can disable it. Disabled flows are great if you have more than one tab. You can keep the other tabs from getting things confused. If you've used the same GPIO pins, for example, in multiple tabs, you don't want them to get confused. So you only want to have one tab running at a time. And you can delete the tab, but we don't want to delete this just yet. Okay, anytime we make a change, we have to deploy. Okay, that cleans things up. Managing our palette. This is where we can import nodes. Okay, these are all the additional nodes above and beyond the basic set that we've imported. And we've imported and installed two nodes, which are very important. It's the UI LED node, that's the one we used. And we've also installed the dashboard node. Let's find the dashboard node. The dashboard node should be in here somewhere. And it's actually a group of nodes. There it is, Node-RED dashboard. And that's this group of nodes over here. So the dashboard node and the LED node are what you want to install first to get going. And you install each of those and it adds it to our little Lego block list over here. And let's take a look at something else that's very interesting. If I go to my dashboard here, I see, let's get rid of this from the previous. Let's deploy this. Let's clean it up. I have an input group and an output group. Okay? And if I edit that, I see that the tab name is IoT. Its width is 6 blocks, and it's supposed to display the group name. If I look at this output group, it's also on the IoT tab, but its group label is out. It displays the label name. And that is, in fact, how we got this block. That's group input group and output group, and the output group has one LED, and it's a red-green LED. So let's look at the output group, and oh my, it has a number of them because I have a number of preloaded logic, but this is where you would normally see just one LED in here. And the input group should have nothing. Yeah, the input group is, in fact, it's empty. You can also see the themes of this. You've got a custom style theme, you've got a dark theme. If we engage the dark theme, it changes the theme of our board to a different background and foreground color, different text colors, but the widget definition in the node definition is the same, red and green for on and off. So I can change theme colors, I can customize it, I can do all kinds of things. But what's interesting is if I change the orientation of this, let's say I put the output in front of the input, that means it's to the left of the input, and I hit deploy, look what happens. My output is on the left, my output group is on the left, and my input group is on the right. Correspondingly, if I change the order in which I have all my widgets in here, by literally clicking and dragging them, it'll change the order in which I actually see those show up here from top to bottom. So I got left and right control, top to bottom control, and I can also change the size of the widgets. I've got down to one block. Let's go ahead and do that. Let me show you that I can change the size of the widget right here from auto to a single block. And if I do that and I hit deploy, and somehow it doesn't like that. So let's switch it back to auto, and we hit deploy, and now it's happy. But it's possible. I have to make sure that that I am using the widgets within each group name properly. So we'll get to more of that a little bit later on. But that's a little bit about the Node-RED desktop. Here I can get information on a node. For example, if I've got the LED node, it shows I'm talking to the LED node, and if I click on this little show help, it tells me about the LED node, how to use it, how to hook it up, etc., etc. If I go to here, then I can go to help screen. This is my debug messages that are coming in. This is a little bit more advanced on configuring your nodes, and this tells me what's being used currently. And back here to the dashboard, we saw that a minute ago of how to control the layout, the actual layout, the site, the theme, etc. So that's a little bit about the Node-RED dashboard. So in the next session, we're going to look at a few more examples. So in this session, I want to talk about Node-RED messages. This is where a lot of people get hung up, can't quite figure out how to handle payloads and topics and other attributes like that. And in fact, it's quite a nice system. And let me give you some examples here. So for example, if I want to use the inject node to trigger on a regular basis, on a repeating basis, I could set it up to repeat every second, and it'll send a timestamp once every second. So let me wire this up to get this going. When I hit deploy, you'll see it start to sending out timestamps every second. And in order to stop this, I simply break the link, redeploy. I can clean up my debug readouts here. I can also inject on a schedule. I can send a payload, in this case a string, at a specific time. And that time of day would be in military time. And I can check the days of the week, and that's when it would do it. If I want to inject a payload with a topic, then I just specify the payload. I specify the topic. In this case, it's a string payload. We can tell because I've selected the string. Message topic is the word label. And if I hit inject, I get label for topic and I get string payload in quotes. So let's clear that out. Now, if we want to filter for a payload, we would use the switch node over here. So you can see a little icon. And let's see how we've set this up. We said we're going to filter in any message payload that equals a string that matches the word yes with a capital Y. So I've got two inject nodes, one with a payload of yes, the other with a payload of no. So let's first test it and see if we can trigger no through the system. It's successfully injected, but nothing came out. However, if we trigger a yes, guess what? We get the word yes in quotes, telling me that that is a string. In fact, it tells me right here it's a string of length 3. So that's how we can do filtering out, or filtering in, I should say. If we want to filter out, then what we could say here is we could select not equal to, which is an exclamation equal sign. That's the not equal symbol of logic. So if it's not equal to 0, then send it out on output number 1. And notice I can add more than one condition, so it can meet a number of conditions all on one particular node, which is really nice, but I can just get rid of this. So if it's not equal to 0, send it out. Okay, so if it's not equal to 0, send it out. Yep, it sent a 1. If it's 0, it did not send it out because that did not meet the not equal to 0 condition. Okay, filter for a topic. We can do the same thing with topics. Let's look for a message property that equals the word topic A, capital A. So I've got two inject nodes, one with topic A equals yes, topic B equals no. If I hit topic A, then it says yes for the payload. If I hit topic B, nothing comes out. So I think you're getting the idea right now. Filter out for unwanted topics, not equal to topic A. If we say this is not equal to topic A, all right, I got topic B, that's not equal to topic A, then it sends the payload of 0. Otherwise, it would send nothing. So that sent nothing. Even though it was injected, nothing came out. Now, if I want to change the payload attribute, then I can use the change node to set the message temperature to be the payload. So let's look at this. The message temperature, okay, the payload is 37 and the topic is blank. So if I click here, then I see this is the raw output of my trigger, which is payload of 37. However, if I look at this, it's now labeled temperature as 37 as well. So what that's done is that it's taken the payload and assigned it to a new attribute called temperature with a payload of 37. And I can use that and either separate it out, reroute it, or split it out, filter it in, filter it out, down the line, downstream, just for temperature. If I want to set just the temperature to a gauge, if I've got more than one attribute in a message. And notice, I've got the payload attribute, I've got the topic attribute, and I've got the temperature attribute and their respective contents in each area, all in one message. And so this is pretty handy, pretty powerful technology. So if I want to route now based on a payload match, okay, I have one payload called message 1 and another payload called message 2. And I can use the switch node so that it says if it equals message 1, send that out to output 1. If it equals message 2, send it to output 2.
So let's see how this works. Here I've clicked on message 1. It sends it out here, and you can see that it highlights when I float over the top of this output, it actually highlights the outline of that debug node. So I know which debug node it went to. If I click message 2, there's message 2, and you can see that it highlighted the second debug node. It came out the second port, not the first port, but the second port. If I want to route based on payload range, then I can do a route. I could say if it's between the number 1 and the number 3, send it to output 1. If it's greater than number 3, send it to output 2. So let's go ahead and clear this. And 2 is between 1 and 3. So guess what? It's gone to output 1, as we can see in this debug node. If I click on 4, it gives me the payload 4 and routes that to the second output port, as you can see right there. So again, a very useful thing to route. Now, if I want to route based on the topic, pretty straightforward. I just look at the message topic. If it's equal to temperature, go to output 1, humidity output 2, pressure output 3, and let's try it. Temperature, humidity, pressure. Temperature, humidity, pressure. I can see that it's coming out on output port 1, 2, and 3 separately as I clicked on those. And if I want to change the range of input values, this is pretty cool. I can map the input range that comes in from 0 to 1023, and I can remap that to a range of 0 to 5. And this is called interpolation and extrapolation. So if I give it a 0, then out comes 0. If I give it a 512, which is halfway in the range, it comes out to 2.5. If I give it the full 1023, it comes out at 5 or 5.00000. Close enough. So those are just a few more examples of how you can handle and filter and find and sort and route all your various messages with different payloads, different topics, and other attributes. So that's a summary of how to handle messages.
So in this session, we're going to look at specialty nodes. This is where Node-RED really gets fun because there's hundreds and hundreds of specialty nodes that you can download and grab and use and play with out there. They're like a huge selection of Lego building blocks. And if you recall our analog input example, we used the ADS1X15 RASPI node that you may recall. That was a specialty node hooked up for the ADS, the Analog Devices 1015 chip. And that was sitting here in our library as one of the nodes that we imported and we got and we used. Now, what's really useful is, why do we want to use a node? How do we find them? How do we know it's good? Well, first of all these nodes are listed in a couple of places. Number one, you can find them if you do a search for Node-RED flows, then you'll go to the Node-RED flows page. I think it's flows.node-red.org. Let's take a look at that actually. Let's do a quick search, flows Node-RED. And you'll see flows.node-red.org. Here's the library. And here we've got in kind of brown stripe, those are nodes, and green stripe are flows. These are actual flow application programs that people have built over the years, and we can do a search. So let's do a search for 1x15. And lo and behold, we see a couple of them. Now, how do we know which one to pick? Okay, what I like to do, let's see if we've got any more here. You say there's more. No, I guess there's not, just these three. How do we know which one to pick? Well, Number one, I like to see the ones that have the highest version number. And later on, when we're able to look at the actual detailed information before we download it, we can see when or how recently that update was done. So I like to look at the one that's best supported and most recently. That's the first choice. The second choice is I look for compatibility or versatility. If it says my chip specifically 1015, that I like. If it says 1X15, then it's probably a multi-chip node that can operate with several sister chips, one of several sister chips. But this one happens to be the one of the ones, well, we'll find out which one we're using here in a second. But what we want to do is let's go back to Node-RED. And in Node-RED, we can go to the Manage Palette selection, go to Install, and then we type in 1X15. And we get those three choices. We see that two of them are installed, okay? And the one I'm using right now is, I believe, Raspi. And also you see this one has a conflict. So you see that these are installed. And over here in nodes, these are all of our installed ones. And we can go in, we can remove it, we can disable it. This one has a flag because there is a conflict here with one of the other similarly named nodes. And if I get that, I have to decide which one I want to use and then clean it up. Okay? So, but let's look at a different node. Okay? Nodes generally come in two different flavors. Nodes that are specific around software functions only, and other nodes, like for example the 1015 node, which is specific to a piece of hardware, which is a chip that's sitting on your breadboard or sitting on a Raspberry Pi hat board or on a Shield board or something else connected up to your Raspberry Pi. So let's take a look at a different Raspberry setup here. And let's take a look at some of the nodes that are software specific. Okay, so here's one called Scan Wi-Fi. That allows me to actually scan all the Wi-Fi networks that are within the range of the Raspberry Pi and get information like their SSID and channel number and a few other things, and tells me what I can log into and actually monitor the signal strength and do some cool things like that. Some other nodes are like the serial bus node for serial in and out. This is the what used to be called RS-232. And this is, you'll see it RX and TX. Those are the two pins on the Raspberry Pi. And that's what this is talking to. Not to be confused with Serial Peripheral Interface, which is SPI bus. That's not what we're talking about here. We're talking about the RX and TX signals to receive and transmit pins on the Raspberry Pi. And you have to engage this as well as things like any other buses like I2C. And you have to do that in the Raspberry Pi configuration menu and under interfaces. Now here's another example of a input for a specific chip. This is a port expander for I2C. You can send I2C signals over the I2C bus with just a serial clock and a serial data pin, and then provide voltage and ground to the chip. And it will actually send that signal, that pin out, that bit. It'll pull a bit high or low on any one of 16 pins. So one I2C bus of 2 wires can control digital inputs and outputs of up to 16 pins, which is a very cool chip to be able to let you expand your I2C part. Now, a pure I2C bus is down here. This one actually lets you scan for I2C devices that are connected. And in fact, the analog chip we saw earlier is a device that's an I2C device, and it will show up. So for the heck of it, let's just see how this works. And let's put an inject node here. Let's hook it up to the I2C scan. Let's put a debug node here. The first port only sends out the output addresses of all the I2C devices are on the I2C bus. This one sends them all simultaneously. So let's go ahead and clear all the previous stuff. Let's deploy this, and let's clear out some of this other junk here from some other things I've got running. Let's go ahead and disable this. That's a way to disable the neighbor flow. Let's go back to this flow. Let's redeploy, and we shouldn't see any of that junk anymore from one of the other flow tabs that I had running. So now if we click on this, you'll see some, oh, okay. What we have to do, I'm on a different Raspberry Pi. Let's do this. Let's copy this over to the Raspberry Pi that I do have I2C devices on. That's, oh, no, see, you can't just copy and paste. You have to export. So here's a good example. So let's export the current flow. That's a good exercise for exporting. Now let's go over to the other Raspberry Pi that does have our Enviro hat on it, that has this A to D chip on it. This is a way to quickly switch and show you how to change software. Then I Control V to paste, and boom, it brought it in, probably as a new flow page, I would imagine. Yep, there it is, look. It brought it in as a new flow page. And then we can deploy, and when I click on this, aha, look at this. Now, these, if they don't say 0x in front, will be digital. If I click on it, I convert it to hex. So you see the 0x1 delta, and I usually use Alpha Bravo Charlie Delta Echo Fox. It's 0 through 9, Alpha through Fox, and I count 0 through 15, which is 16 unique positions. That's hexadecimal, and that's what I'm seeing here. So 0x or hex 1 delta is 29 decimal. So 29 decimal, 41 decimal, 73 decimal, and 119 decimal. And it actually happens to be, I think the A to D is on hex 49. Let's take a look. Was it on hex 49? Yep, look at that. 0x49, which is 73 decimal, or 0x49 is the same thing. So there's an example of another specialty node that I can quickly bring in and scan for I2C devices. Then how do I talk to them? I can use this node to pull in data from an I2C device. Let's take a look at that. And we can see that this is the bus address, and that's usually in decimal. So that would be 73. Then I put the command, which is often the sub address, which is in other words, the register address, registered location of the different values where they reside inside the chip, and the number of bytes I want to read. 1 byte, 2 bytes, 4 bytes, whatever I want to pull out, starting at that sub address out of a list of possible internal addresses in the device that's sitting uniquely at the bus address up here, which is decimal 73. And I can do the same thing with the output node. I can determine where I want to send it, what address, to what register, how many bytes I want to send it, what is the payload I want to send, and that's how I get data in and out of my I2C bus. Let's take a look at a few other devices, nodes that we can use and we can download. Now we'll actually do a quick download of one of these nodes, and you'll see how that works and why. And you'll see how I like to actually select which ones to download. So we've got some other specific devices, buffer nodes. This is another A to D chip, and we've got Boolean logic here in purple. We've got, of course, our I2C. We've got a whole family of OLED devices which can send text, can clear an OLED, it can dim it, invert it, turn it on and off, have pixel by pixel access to each pixel in the OLED, check its battery, have a Wi-Fi symbol, battery symbol. There's a whole bunch of draw a line, there's a whole bunch of things. So this is kind of like a toolbox for sending stuff to your OLED. So another hardware-based family. Just like the dashboard is a family of nodes, the OLED is a family of nodes here. So let's go over here to our little Raspberry Pi Zero and let's see what it takes. Let's clear this out and see what it takes to actually import a new node and why. Okay, why and how. So let's go here and let's look for a chip 23017. And there it is. There's two chips. There's one called chip. This one's called contrib.1 MCP 23017. And here's another one with a very similar number. So, as I said before, I like to look at the more recent one. This one's 6 years ago. That may not have been updated, or maybe been superseded by one of these two. And these two look like essentially the same thing, but the one that says contrib is a standard used by GitHub that is a much more conventional, standard, established way of building nodes into a library at GitHub for download. That's where all this stuff lives. Now, if I click install, don't worry. It doesn't go ahead and install. It gives me a choice. It says cancel, open node information, so I can look at it before I install. So that's what I always do. I like to look at it, and this gives me a heck of a lot more information. And it says it requires the I2C bus and gives me some information about the pins. Don't allow already selected bits to be selected again. When a node is deleted, removed from IDS, blah, blah, blah. And so now it creates another tab in my browser that gives me this information. And I can go back and do one of two things. I can either cancel out and say, nope, that's not the one I wanted a different one, or I don't want this at all. Or I can go ahead and install this. Once I click on install, notice that it's giving me this funny little symbol here, this active set of bars, telling me that it's in the process of downloading. Once that's done, I'll get a notification at the top of Node-RED saying that it's either been installed successfully and added to my palette over here on the left, or it hasn't and it's failed for some reason, and you have to go in and check why. Maybe it's an old node that hasn't been updated or supported, or there's some other conflict or problem, or maybe there's a conflict with a node that's very much like it, that's already installed, and you've got to either uninstall the previous one or not install the new one and just use the previous one because you have one that's already in the system. So that's it for today. Look, there we go. 3 of them, chip, input, and output. So we can close that. And let's see where it is. Let's see where it decided to install. Here it is. Look, there's our input, there's our output, and should be one of a similar color down here. No, just an input and an output. So I've got my 2 nodes for the 23017. I can pull in data, I can pull a bit on that chip, high or low, and it'll show up into my Node-RED flow. I don't have it hooked up to my Raspberry Pi right now, but you get the general idea. This is how you install nodes. So much for specialty nodes. Don't worry too much about playing with nodes because you can always uninstall them. Let's take a look for completeness here before we go. And we can look at our nodes and we can remove. Usually we can disable it. If we have a conflict, we can disable it, but we can also, in many cases, remove it, unless it's in use. Our I2C is in use, so we have to get it out of our flows to be able to free this up and then uninstall or remove the I2C in this case. And here we've got some that need updating, and you can see which ones need updating here, and updating would be a process just like installing. Sometimes when it's uninstalling, it'll tell you you have to restart Node-RED for the new node to take effect. So don't be too surprised about that. So that's it for installing new nodes. Have fun. Feel free to play with it. These are Lego blocks. Everything is changeable and fixable, removable, and cleanable. So that's it for specialty nodes. Till next time.